Hi, I'm Kaushik, CTO of Menlo Security. Welcome to part 2 of the overview on the Menlo Security Isolation Platform. In the next few minutes, I would like to show you the isolation platform in action, as well as take you under the hood and show how the technology actually works. Let me start with a normal browsing session. I'm pointing my browser to cnn.com. As you can see, the page loads quickly, scrolling seems pretty smooth, and mousing over the elements causes them to change color and animate. Your typical experience. Now let's take a look and see what's happening. My browser connected with cnn.com fetched the content for the page, executed the code, and generated what's called a rendering tree, which the browser uses to paint my screen. Let's take a look at that code. Here's the content that was delivered to my browser for the home page of cnn.com. It contains many lines of code and includes content from dozens of other sites, including ad networks and who knows what. There's also executable content like Flash, which for all we know contains zero-day malware. There's no way to reliably detect if the content from CNN.com was good or bad, and that's why we keep seeing the breaches over and over again. Let me show you the exact same experience now going via the Menlo Security Isolation Platform. User traffic is proxied to the platform, which browses the web on the user's behalf. The user's web session is fully executed in the platform, fetching content, executing, and rendering, but only the rendering information is delivered to the user's browser, which could be any of the major browsers out there: Chrome, IE, Safari, or Firefox. Let's see what that looks like. I'm going to manually proxy my web session through the Menlo Security platform by prepending the URL for cnn.com with safe.menlosecurity.com. In an actual deployment, you don't need to do this. The proxy is automatic, and so the user's browser bar just shows the target's website. You see that the page loads quickly and the scrolling is normal. It's a natural experience, no different than browsing the web directly. However, when we look at the source code for the page, you see something completely different than before. The only code delivered to my browser is this. These are just headers. The only active code is a single line of JavaScript, whose only function is to synchronize the visual elements in the isolated browser in the platform with my local browser. None of the original code from the web ever leaves the platform, so there's no chance for malware to reach my device. There are two technologies that are the foundation of the isolation platform. The first one is disposable virtual containers, and the second one is adaptive clientless rendering. Let me go over both. The Menlo Security platform goes between the web and the user. The platform is available as a public cloud service and also as virtual appliances that you can run in your own data center. Users' web requests are directed to the platform via a proxy setting on the end user's device or proxy chaining with an existing web security gateway. For each request, the platform allocates an unused container called a disposable virtual container from a pool. Each container starts off with a clean OS and a clean browser. Since the containers are already spun up and ready to go, there's effectively no latency involved. The isolated browser fetches the content from the website and fully executes it inside the container. Only the visual elements and the rendering information is delivered to the user's browser on their own device, free of any malware. When a user clicks on a new domain or closes a browser tab, the associated container is disposed, so malware has no chance to persist. As you saw before, all of this is completely transparent to the user. So how do the visual elements from the isolated browser get to the user's browser without any plugin and without any endpoint software? That's the function of the adaptive clientless rendering. Adaptive clientless rendering technology synchronizes the visual elements generated in the container with the user's browser. Unlike technologies like VDI, which send pixels to the end user's device, ACR technology selects the optimal native encoding for rendered content, text, graphics, audio, video, etc., and delivers the display information using standard browser rendering objects. That's why you see the scrolling to be smooth, and features like copy, paste, print, autofill, they all work normally because the user's local browser is using standard rendering objects to paint the screen. Active content like Java and Flash are also executed in the container and encoded into passive rendering information, so no active content or malware ever reaches your device. Another cool thing about ACR is that it works without any client software or plugins. Remember the single line of JavaScript we saw when we looked at the source code for CNN.com using the platform? That script establishes and maintains a secure channel for ACR to do its work. It means you can roll out the Menlo Security platform to all of your users without installing any endpoint software. Enterprises of all sizes, including global corporations, are now deploying Menlo Security Isolation Platform to open up more of the web while simultaneously reducing the risk of malware. Thanks for watching, and see you again soon.